Okay.
So what we do, we'll start from this kind of functions here, which we call it financial functions. Let us look on financial functions. Then the last part, which you left me with, which was under introduction, I'll be able to look up so that I can be able to finalize on the first part that you are looking on this particular given exercise. So in this case, let us just start from financial functions so that the AMRAN can have a clear information on how you can be able to maneuver on those particular given what functions. So to start, I can say, when you look at these functions, we normally have different types of functions. We have PMT, we have PV, FV, and type. But now we have the sample spreadsheet that has been used, which can be used to communicate this kind of what information. So this spreadsheet, when you look at this case, we have such a kind of a data sheet, which has been shot in this particular given program here. So this data sheet, when you look at it, we have calculating the mortgage payment. We have also loan, we have interest and number of what? Number of years. So we normally use, for example, when you have this one, let me just key in very fast so that you can be able to check on it as we do calculation. So in this case, we can decide to write the heading or we can skip the heading, but mostly when you want to calculate the mortgage payment, if someone borrows a loan of 100,000 and we have an interest of 8% for 25 years, so you need to calculate how much money will she or he be paying every month so that he can be able to clear this kind of money. So in this case, we can have here loan, we can have loan, we can also have interest rate per annum. Interest rate per annum. Interest rate per annum. We have also the number of years. Number of years. Then we have payments. We have your payment. So since you have worked in account department, you will be able to understand these formulas very fast. The payment here. So payment. So right here at the top here, payment here. So this one is just calculating mortgage payment. So just right here calculate mortgage. So for you to calculate mortgage payment, assume a person took a loan of 100,000. In this particular given case, so he or she need to pay an interest rate of 8%. An interest rate of 8%. 8%. Then for 25 years. 25 years. So in this particular given case, when we look at this particular payment here, for it to be made, we normally have our payment monthly, which will be calculated as what? PMT. PMT, when you look at it, they say this function returns the principal for an investment based upon the periodic, constant payment and constant interest rate. So in this case, for you to apply these kind of functions here, you come and what? When you look at the function itself, they are saying you need to calculate the P4. Our P4 here, when you look at it, it is showing what? The loan amount. You divide by 12. What we divide by 12? You are converting the loan in form of monthly payment. Then from there now we have also our P5. P5 here is our interest, is our number of years. So if there are number of years, we need to work per month. So if there are 25 years, we need to see how many years are those, how many months are those for 25 years. Then from there now we have P3. Our P3 is the loan that you have been given. So what I've said, to interpret this kind of function, we have been given a loan of 100,000. Then you need to be able to pay with an interest rate of 8%. Then the number of years is 25 years. So for you to work out this formula, you need to change the number of interest that was given by annum to monthly. Then after changing it to monthly, you also need to change the number of years to monthly, so that you can be able to multiply the profit, the loan that is given. So when I calculate here, what I'll need to do, I'll click under payment here. I'll click under payment, then I just say equal to PMT. When I type PMT, kindly reduce the noise on your side. When I type equal to PMT, I'll be able to.
Excuse me, Manu.
Yes.
PMT inamaanisha nini?
Payment monthly. Yeah.
Nati?
Payment monthly term.
Okay.
So in this case, when you look at this kind of value here, we have our PMT here, which will be what? We need to change the number of interest rate per annum here, which is 8%. 8%. So we need to multiply. We need to divide 8, which is 12 months. For a period of 12 months, we need to pay 8% interest. But now in this case, we need to convert per month how much you will be paying or you will be paying. So that's how I'll be able to click this case here, which is P3 in our case. P3, then we divide. You'll be able to divide what? 12. After dividing 12, you'll separate with a comma. Then you take the number of years here, which are 25. In 25 years, you want to see how many months are there. You'll just multiply by what? You'll multiply by this case. After multiplying by 12, you put a comma. Then you now multiply the features there by the loan amount that you have been given here. And this loan amount, which is what? 100,000. So just 100,000 in this case here. So when you are to get the monthly payment, now you just close the bracket here. After closing the bracket, now it needs to do to press enter. Like this. So once you press enter, you get the full amount, you will be able to pay this kind of money. This kind of money. So in that case, when you look at it, the formula becomes very clear. As long as you understand how it's being interpreted, you'll be able to work out that of what monthly payment. So in this case, when he pays 721.82 times number of months, you get that you'll be able to reach what? $100. So these are dollars. You'll be able to reach what? $100 in this particular case. So in that case, that's how you can use PMT. We have another case where we have, in this case here, when you scroll down, you'll be able to see also another function, which will be able to meet, like PPMT. In this case, when you look at PPMT, also you'll be able to understand the PPMT also, it works differently when you are using this kind of what? Formula. So in this case, when you look at this one, principal on payment, which is PPMT, principal on payment. So here we got our payment monthly maybe 771. Now we want to see the principal on payment here. So for you to get the principal on payment, the same criteria applies now. But now, when you are counting the years, you start with the first year. That's why I'll be able to add here. Payment starts in the first payment made, which was the current payment, which is first payment. First payment. So we can say, we can add here current payment. Our current payment for the first year was what? It starts from 1.
7.
Yes?
Can you call it 771?
Yeah, so this is 1, which is the current year. When you look at this one, first payment here. So when you want to calculate the principal on payment here, you are seeing principal on payment. In this case, it would what? Our P4. When you look at P4 here, it was what? Our interest. So we automatically change the interest to per month. We want to calculate the interest here per month. So which would be what? P4 divide what? 12. 12
By
is the number of months in that given first year. Then we have P6. Our P6 is the current payment period. So you need to indicate the first period, which was what? Which was 1. Then you'll take the what? Number of years. You multiply by 12. By 12. Then you multiply by the loan itself. So in that case, when you look at this particular explanation, for you to get PMT, in this case, you just take what? Equal to, you just type equal to PMT, in this case, then you close the bracket. When you close the bracket, you now take what? Interest per annum, which was 8. You divide 12 months. Then you put a comma. You will click the current payment period, which was the first one. You put a comma. Then you come and multiply the number of years, which is 12. You multiply, which is 25 multiplied 12. And remember, 25 is in form of year. Right? So when you want to change it into month, you multiply the number of years by 12. Then once they are done, now you'll be able to click the loan amount here. So you'll be able to get the principal payment for every month, which would be what? The 105.15 here. So the interest on each payment we have also there. When you want to get the interest on each payment, you see the total payment was 770. You can just easily subtract it. Interest. You see that when you pay 100, the interest comes with what?
Manu, your voice is. Mama, it's because of network.
Okay, so what I'm saying here, we have our payment for the first year, which was what? For the first year, which
771.
Then for this particular given case, the principal was 105. So to get the interest for the first month, it would what? 771 minus 105. So in this case, it will be 666 what? $0.67. But in this case, also we can use a formula so that we can be able to calculate IPMT. The IPMT, which we have also seen it here, but for the clever person, you can just subtract once okay, the PMT, you subtract what? PMT, will get the IPMT in this particular given case. But for you to find it, we can also use the formula that has been used here. So the formula here, it was showing P4. When you look at P4, it's always the interest here. You divide 12. Then we have P6. Our P6 is here. Our P6 is here. So this particular given P6, it was the current period of payment. Then from there now you take the number of years, you multiply by what? By 12. Then we have our P3. P3 here, you are seeing it's what? The loan. The loan. Here. So in that case, when you look at also this one, it's directly, but what will make it change? It is the IPMT. It is the IPMT. Let me pick up on here. Yes. So in this case, you just also come here, you calculate the IPMT. So the IPMT, you can just say equal to IPMT. In this case, you open the bracket, you take the interest per annum, which was 8% here. So this 8% you divide by what? You'll divide it by 12. You divide it by 12. After dividing it by 12, now you have also to select the current payment period, which was the first year. Then you put a comma here. You put a comma. After putting a comma, now you come and select the number of years. The number of years you multiply by what? By 12. you multiply by 12, then you can be able to do it. You can be able to multiply the loan itself. When you look at this case here, you can just multiply the loan in that particular given case. So in that case, when you look at that particular given scenario, when you use IPMT, it will return the profit for every payment. But if you use PMT is the principal on payment, So when you press enter, you'll see it will put 666.6767. So that's how you should be able to understand the financial functions here. We have also another scenario which is using like the NPV, net present value. This function mostly calculates the net present value on investment. For example, when you put some amount of figure somewhere, which amount will you be able to get after a specific period of time? So that's when we come up with the NPV and so on. So this kind of value here, let us look at this kind of value. The present value of an unique irregular payment. A unique irregular payment. For example, if you have been dropping somewhere, 2,000, 3,000, 4,000, 2,000, 1,000. So you want to get your net profit value for this particular kind of value. What will you do in this particular given case? Let us say you are in a Chama. You have been saving a certain amount of money, which is 2,000, which you have seen it there. We have also 4,000, 5,000 for a given period of time, which may be 12 months. For you to be able to get the total amount of money that you'll be able to save for a period of 12 months, you now come up with what? The NPV function. The NPV function also, it can be applied when you are paying some kind of what? Item. For example, if you pay on a hire purchase, if you buy something on a hire purchase, you'll be paying small amount of money for every month. So in this particular given case, if they ask you to pay for 7 months, then they give you a discount of 6. You'll be able to calculate the amount that you'll be able to pay. For example, if someone offers you a TV, then he says, this TV, it is worth 50,000. But I want you to pay at a small given amount of what? Money for a period of what? 2 years. And if you clear within 2 years, I'll be able to give you a discount of 6% or 10%. So how much money will you be able to pay for those particular given amount of period? So in this case, we come up with NPV. As in a scenario, you normally see those people take small phones, which they normally keep them on loan. You pay a little amount of money, like lipa mdogo mdogo. So this lipa mdogo mdogo is applying the principle of what? The NPV to come up with the total amount of money that client can be able to pay. So in this case, let us come up with this kind of values here. So what I'll do, I'll click sheet 2, this case. So we'll have our period here. So the period will be 1. We can have 2. So if you want it to be out of scale, you can just highlight and then you drag it down here. In this case, you can have those kind of period here. So we can use 8 depending with the numbers. Then the payment mode, it was 2,000 like this. So this 2,000, it's up to the third like that. Then we have 2,500. So 2,500 also, when you look at it, we can drag it. After dragging it, we can have 3,000. We paid 3,000 twice for that kind of payment. So in this case, we have here our payment, which we have already entered. So for you to find the net present value, if you have been given a discount, we say discount of what? Our discount rate is equal to what? We can say, let us use that example so that you can come up with our own discount, so that you can also prove what we are typing here is the true features that is in the exercise here. So in that case, we can have, try to put my percent. Yeah. So this is our percent, 6% discount here. So for you to find the net present value, which we call it NPV, NPV will be given as what? Is equal to, when you look at this particular given function here, they are saying NPV is equal to, you take the rate, you multiply the amount of collection. You take the rate, you multiply the amount of what? Collection. So the rate here, first you write NPV, then into bracket. After typing into bracket, now you'll be able to come up with what? Our interest rate, our discount rate to what? 6%. Then you multiply the payment that he or she has been making for a period of what? 7 months or 7 years. So once you do so, now you come and close the bracket. After closing the bracket, now you just hit enter. You'll find that that kind of amount, it will be added there. So the reason why it's showing 14 something, and this one is 14,011, we had added another unique figure here, which was 4,000. This was 4,000, so that's why it makes it different. But in case you want to apply the same, you can copy the exact values that are in this spreadsheet here. So we have the first value, the first 3 digits, they are in thousands, 2,000, 2,000, 2,000. Then we have 2,500, which is here. Then we have 3,000, 3,000. From 3,000, now we have also 3,500. So when you change that figure, once you press enter, it will be the same. It will be the same in that particular given case. So that one, they had rounded off to the nearest whole number. So that's why you are seeing it's $14,011. But this one is $14,010.61. So when you round it to the nearest whole number, it will be 14,011. That's the same answer that you'll be able to get in this particular given formula here. Rahman, Sahara. Hello?
Yes,
I hope you are getting what I'm explaining here.
yes, I'm following.
Yeah. So the NPV now you can be able to apply. Then we have future value, which we call it FV. Our future value, if you plan to save a regular amount of interval, the FV function calculates how much money will you have saved at a specific point in future. So the FV mostly it applies when you are saving. For example, you can go to a bank, then you open a fixed amount account. So that you'll be depositing maybe 4,000, 4,000, 4,000, 4,000 for a period of 12 months. So that period of 12 months, when you'll be able to calculate the total amount that you have saved, this kind of value it will be shown by the help of what? The FV function. So this FV function mostly plays a role in presenting the future value for a certain period of month. So when you look at this case here, we have shown in this particular given case, we have our payment, period of compounding interest, number of years. For example, when you have a bank account, they normally advise you to open a fixed account. And fixed account, you normally ask for the interest. If you save for this kind of money, without withdrawing, how much money will you have at the end of that particular given period? So I don't think this one is a new thing for your side. You have been there in the sector and you understand how people open the fixed account. And this fixed account, they are normally provided with an interest. That interest, it means the money will be increasing every time you are saving in that particular given bank account. So in that case, that's why you will be able to see this kind of values here. When you look at this case, the future value mostly it applies when the amount that you are collecting is of what? The same for every month or every year. For example, if you set a target, I want to save 2,000, 2,000, 2,000, and the interest rate for that particular given money is growing maybe by 6 or by 7.5, how much money will you be able to get for a period of what? 20 years, or it can be 20 months. 20 months. So in this case, when you look at this particular given case here, we can have our payment. When I copy this value here, we have our payment here. So I can just type, I can type here payment. I can type here payment. After typing payment, we have period, compounding interest, period compounding, period compounding interest, period compounding interest. After period compounding interest, we have a number of years. Number of years, like that, number of years. Then from there now, assume you are paying 2,000 every month. Then you have your interest, which is 7.5%. Then you have a number of years to be maybe 20. So how much money will you be able to get? You'll be able to use the feature what? Feature value in this case. So the feature value for this kind of values, for you to be able to calculate, they have shown you to be FV is equal to what? P4. And where is our P4? P4 is the interest rate. Then you multiply P5. Our P5 is what? Number of years. Then you multiply the payment that he or she is paying. So that's why you'll be able to get what? Equal to FV. When you type equal to FV, now you'll be able to click. You just, you take the interest, FV, which is what? The interest which you have shown here, you multiply it to the number of years, then also you multiply it to the what? To the payment. So in that case, so the order of arranging the values is the one that you should be able to determine. But if you don't arrange your values very well, you'll be able to get the wrong figure. That's why when you are typing, it seems to be simple, but you need to be able to interpret. In case someone can be able to ask you, how can I get my feature value for this kind of money? You need to understand the formula by your offer. For you to get an interest, if you have been saving maybe 3,000 every month, you'll be able to take the interest rate that will be provided by the bank. You multiply the number of years that you'll be able to save. If it will be in years or in months, you multiply the number of months, then you come and multiply the payment itself. So you get that the total amount that will be able to have accrued together for a period of 20 years, it will be this kind of value here, which will be what? It is 6,609.36. So let us just try to figure out, assume we have not been able to arrange the figures correctly. How will you be able to understand that this figure is wrong? Let us just try to test it as a scenario. Equal to FV. You type equal to FV into bracket. Assume we want to use this one, you just want to multiply them directly. Will you get the same answer? So in that case, let us see. You will not be able to get the same answer. So that's why it's good you understand the order naming the cells. Once you understand, now you get the same answer the way you have displayed in this case here. You take the interest rate, you multiply the number of years. After multiplying the number of years, you come and multiply. So in that case, that's how you'll be able to work with this kind of financial functions. So financial functions, mostly they are used to compute financial information or financial figures. We have looked about the IP. We have checked on the PMP, We have also checked about IPMP. We have also checked about the NPV. We have also checked about the FV. In that particular given case, it will be very simple when you understand the formula. But once you don't understand the formula and how it's being applied, in the case where you want to apply, you'll be able to get what? You'll be able to get a wrong value in that particular given case. So it's good you apply the correct formula and you understand how that formula is being applied. So the other things here, they are very simple, which you can be able to understand it very fast before we can end our class here. Because I want you also to revise on the financial function so that you can be able to understand. When you look at mathematical functions, mathematical function, we have things like round. Round is used to round values. For example, if you get a value in decimal numbers, you can be able to round it up to the nearest whole number or to the specified figures. For example, if I want to round this value, I can just copy this data of mine. When I copy this data of mine, I'll be able to click it here. If I want to use the round function here, maybe I want to round this figure. I want to round this figure to the nearest one decimal. If I want to round it, I'll be able to click equal to round. So we normally have different types of round. We have round, round down, and round up. Those are different types of values that you can be able to use. So in that particular given case, you will find that those values be applied differently. So when you say round, assume you have such a like a figure which is 303.155 and so on. You want to round it to the nearest two decimal place. So it will just count 1, 2. Then it truncates. If you want to count, if you want to round to the negative, you'll be able to see equal to round -2. -2, you'll see in this particular given case, it will be 300. 300, it means what? It's not more than 350. So it will round off those values to the nearest what? -2, which will be 300 flat. We have round up and round down. Round down, when you look at it, in this case, it will be able to truncate the value that you want. So round down is like round, but it can have a different meaning based on how it has been used here. We have round up. Round up now, it makes the figure that is before it to increase or to reduce. So when we look at this case, let us just apply it here. We want to find that we have round here. We want to round those values to the nearest two decimal places. So let me just have it here, equal to round. When you have equal to round into bracket, you want to round these values, which is what? B6. Then you can see you want to round it to one decimal place. Once you are done, you just press the bracket, you press enter. You'll see now it will be able to round it. We have also the round down. Let us see how it will be able to round down. So equal to round down. When you tap equal to round down, you can be able to open the bracket. Then you click here. You put a comma, then you can round it down to 1. You round it to 1. Why do we say 30? Why do you say 30? Because it will only truncate 30, and the figure after it will change it to 0. We have also round up equal to round up into bracket. You'll round up this value here. After rounding up, now you can press enter. Then you want to round it to the nearest one. Then you press enter. Nearest one, when you round up, it will increase. When you round down, it will be able to reduce the values in that case here. We have the absolute. Absolute, this function returns the absolute value of a number. A number without a sign, for example, a negative value becomes positive. So negative value mostly it becomes positive, the positive value. So in that case, assume you have this kind of values here. We have so let us have 6. We have 6. We have 500. That case. So we want to find the absolute value for this one. Even the negative values now they are there. You can be able to use it. So you just come and type what? Up. Apps. After typing up, now you click the number. In this case. Then you close the bracket. So apps, it shows the absolute value for any given figure. So in that case, you just press not. And when you press enter, it will return all positive values, it will be positive. But negative values, it will change to positive like that. So that's how you should be able to understand. So you are seeing positive value, they are changing to positive. And negative, they are also changing to positive. So in that way. So in that case, you are seeing it.
Sorry, I lost connection.
Yes.
Sorry, I lost the connection, but then I'm back.
This one.
But I'm not seeing your screen. Yeah, screen is not visible to me.
So that's why you should be able to see absolute value is used to negate the negative values on our value. We said for you to use, you just.
You're not you sharing your screen because in an Bernard is sharing his screen but don't anything. Because ni kama ni venye nilitoka ikatoa.
Okay.